for agreeing to do this session. I would just like to quickly introduce myself. I'm Pooja Kulkarni. I'm the founder of Psych rstats Club. Psych rstats Club works towards making statistics and R more accessible. And today we are very happy to be collaborating with Rafael Bastos. Rafael Bastos has completed his M.Sc in Psychometrics from Sao Francisco University. He runs a consultancy in statistics and psychometrics, and he recently launched his book on advancement in psychometric theory and measurement for psychological sciences. He has done a lot of work to make psychometrics more accessible, and we are very happy to be collaborating with him today for this workshop on confirmatory factor analysis in R. So, without further ado, I would invite Rafael to take the floor.
Hi everyone, thank you for having me and thank you for being here on a Sunday. So I know this is hard. I know everyone wants to learn now, but let's begin talking about confirmatory factor analysis. First, I'll try to share my screen here. Uh, Please let me know if you can see it.
Yeah, we can see
So
it.
the Can you see it? Okay. So the confirmatory factor analysis is a part of the validity we seek in our instruments. Like in psychology, we usually have instruments to measure, for instance, depression or well-being. And this is one of the steps we have to seek this type of validity. And it's called internal structure validity. And to be more specific, CFA is a multivariate statistic. So it helps us to estimate the structure of an instrument. So basically what it wants and what it answers is how well the items represent the latent variable. So first we need to know which model to test, for instance, which items belong to which factors. I'll give an example with depression and subjective well-being. So this is a CFA representation, and let's assume that we are measuring depression. And if the theory says that depression is a single factor model, then this N here is the factor of depression, and it explains the scores in the items. So basically, when we calculate a mean of the instrument to have a score of depression, we can do the same thing for a CFA model, okay? So we'll test if this model where we have a calculated mean, it's not a mean, but it works the same way. If the latent variable scores explains well the scores in the observed variables. But we also can have a model with more factors. For instance, a model with subjective well-being, where we can have like three factors with life satisfaction, positive effects, and negative effects to explain the items. Okay, so CFA has some main assumptions that is not strictly uh, from the CFA, but more for the factor models as a whole. For instance, there is a assumption of linearity, so the relationship between the latent variable and the items are linear. And also this relationship is causal, so the scores in the latent variable causally affects the scores of the person in responding an item. The latent variable also is continuous, so there is a score here that is continuous, it's not discrete. And there is an assumption of local independence, which means that the correlation between, for instance, item one and item two exists only because they have a common cause that is the latent variable. So if we have a depression latent variable, this correlation between I am sad and I cry in the shower only exists because they are conditioned in the depression latent variable. So for model specification, I brought some matrix multiplication here. So I know this might be hard, but I'll try to explain it in a more concise way. So we have that the scores of the items x1 to x8 is caused by the latent variable and the relationship between the item and the latent variable, which is the factor loadings, plus and measurement error. Okay, so in confirmatory factor analysis, uh, we have a we usually set some factor loadings to be zero. So these first four items only load in the first latent variable, and the last four items only load in the second latent variable. So we fix the factor loadings to zero, so we can identify the model and specify the model. And we can see also that the covariance between the latent variables and the measurement errors is assumed to be zero, and the expectancy of the errors is assumed to be zero as well. So for model identification, like we need enough information to calculate CFA. And how do we calculate that we have enough information or not? Imagine we have four items that we measure for one factor. So we have four factor loadings to estimate and four measurement errors to estimate for each item. So we require eight informations to calculate the CFA. So we have eight information required. And how many information do we have? We have four item scores, which is the score of a person in a liquor type item, for instance, and six correlation between items. As we can see here in the correlation table below, it's an example. So the correlation between item one to item four, we have six correlation between the items since the main diagonal is equal to one, because it's the correlation between the item and itself. And the upper triangle is also the same as the lower triangle, so it's a repeated information. So we have four item scores and six correlation, and we have 10 information available. So we can estimate the model of a single factor model with four items because we have a lot of information available. So it's easy to assume and calculate that the required number of items to estimate in a single factor model is three, because we have the eight information, we have the six information that are required, and we have also six information available. So the degrees of freedom here is like the information we have minus the information required. So if the degrees of freedom is less than zero, the model is unidentified and nothing will be estimated. If the degrees of freedom is equal to zero, the model is under-identified and only factor loadings will be estimated arbitrarily, and no fit indexes will be generated. And if the degrees of freedom is more than one, we have an over-identified model and everything can be estimated. So, okay, we know how to estimate the factor and how to specify the model, but how how do we interpret this model? So we have some goodness of fit index or just fit indices to test whether the theoretical model reflects the data well. So several fit indices have been developed to try to achieve this, so we can see if the data and the model are going hand to hand. So there are basically two main fit indices that we work nowadays. So there is the absolute fit indexes where you have the RMSEA. The RMSEA see how far the fitted model is from a perfect model. So perfect is a model that can perfectly predict the values of the observed correlation. And incremental fit indices such as CFI and TLI evaluate the performance of the fitted model compared to a baseline model, where the baseline model is the model where the variables are independent. So we have the worst possible fit. So in general, The goodness of fit indices see the difference between the observed correlation matrix and the implied correlation matrix from the model. And we have some recommendations in the literature. The one that is mostly used is from Hu and Bentler, 1999, where the CFI and TLI should be above 0.95 and our MSCA should be below 0.06. So you can have more further details about the theory behind it in my book, and I'll ask Pooja to share this with you all. And these are the references I used to build this slide. So without further ado, let's work using R. So to prepare the R environment, we first need to install the package Lavan to run the CFA, and we will also install the package Psych to use its data set, but Psych will not run the analysis. Who will run the analysis is Lavan. Okay? So you use the function install.packages and put the name of the package here and tell the R that we will be using this package. So we'll just put library Lavan and library Psych and we'll run this. Okay, it's now loaded in my computer. And first we'll have I'll try to fit a correlated model. So as I mentioned before, we need to have the information of which model we will test. So we have to know the theory behind an instrument, how many factors we have, which items represent which factors, and whether or not the factors are correlated. In this case, we will have the correlated model, but we will see how to do a non-correlated model as well. So let's use the model from Hosinger and Swanford, 1939. But this is not the exact model they test, but I'm just using this as an example. And we'll save the model in the hs.model variable. So to we first need to specify the model to use Lavan. So we write here that the visual latent variable is composed by items x1, x2, and x3. As you can see here, we have this equal and tilde here. So this says that in the left side, we have the latent variable, and in the right side, we have the items. So everything on the right side is the items, and everything on the left side is the latent variable, okay? So this first latent variable is composed by items x1, x2, and x3. The actual is composed of the items x4, x5, and x6, and speed is composed by the items x7, x8, and x9. So we finish the string putting putting this, and we can now run the analysis. Okay. So first, save the object of the CFA in the CFA.fit, and in Lavan we have a function
Rafael,
called.
uh,
Okay.
uh, sorry to interrupt. I still see your Google slide screen. I don't
Oh, I'm
see
sorry.
the. Is it just me? I'm not sure. Um, can
Let
someone put
me
in chat if they are able to see?
let me see here.
Okay, yeah. I think
Yeah.
others are able
Okay.
to see. It must be something. I'm sorry for interrupting. Please continue. Yeah.
No worries. Okay, so we'll save this to a CFA.fit, and Lavan has a CFA function that is just CFA, and we put the arguments here. So the model we test is equal to the model we set up here before, hs.model. Data, we put our data with the items. In this case, the Lavan already has this data set, so we don't have to set up the data beforehand. We put an estimator, so this is the maximum likelihood estimator, which will deal better with these continuous items and says if the variables here are ordered or not. If we have ordered variables like 1 to 5 in a Likert scale, in this case we don't have a Likert scale, so we will just run this. And to have the results, we'll calculate the summary. We'll do the summary of this object. and ask for fit measures, so that goodness of fit statistics, and ask for standardized solutions so we know how to interpret this better. Okay, so we just run this, and the results should be here. So we have the number of observations. So there is like 301 participants. And the model test user model is the chi-square goodness of fit index. It's not it's not usually used, but it's reported. So we report this because the other fit indexes are based on the chi-square. So we report this chi-square. And we have this CFI and TLI here below. We can see that the interpretation of this, we would say that this model is not the best model to explain the data since it's not above 0.95. And below we also have the root mean square error approximation, where it's also not a good fit for this model, for this data, since it's not below 0.06. We also have the the lower confidence interval and the upper confidence interval of the RMSEA. And we also have the standardized root mean square residual, which we usually do and interpret in the same way that as an RMSEA, okay? And below, we also have the factor loadings here. So we see that the first item is fixed to 1 to be used as a parameter to interpret the other items. Okay, so for each factor, we fix an item to 1. So this first item of the factor textual is also fixed to 1, and item x7 of the factor speed is also fixed to 1. That's why we don't have the p-value of those items, okay? Because we are fixing the parameter here. But we can interpret this factor loading looking at the last column, which is the standardized solution. So it standardize the factor loadings based on this fixed parameter and based on fixing the parameter of the latent variables as well. So we see that we have a 0.62 factor loading here, which is considered medium to high. In exploratory factor analysis, we usually put a cutoff point to be above 0.40 or 0.30 to consider that the item is good. But in CFA, we usually don't have this type of interpretation. But we also can look at the p-value and say, okay, it's explaining the magnitude of the factor loading is more than simply noise. So below this, we also have the covariances, where you see the covariance between the factors here, visual and textual, visual and speed, and textual and speed. Okay, as I mentioned, the Lavan will put the correlation as default. So after this, we'll see how to set the correlation without fixing it to 0. Okay. And also we have the variances of the variables here with the variances of the items and the visual, text, and speed variance. So, okay, let's set an orthogonal model. So the orthogonal model is in uncorrelated factors. So the uncorrelated factors, to set up a correlation, we need to put this double tilde here. So the correlation between visual and textual, we set this to 0 by multiplying 0 with the textual and saying that this parameter of the correlation is set to 0. Okay, so it's very easy, very intuitive to do this in Lavan. So here we're setting the correlation between visual and textual to 0, visual and speed to 0, and textual and speed to 0. Okay. The other arguments are the same. So we have the model, the data, the estimator, and setting the order to be false and asking for fit measures here. Okay, as we can see, the CFI and TLI are actually worse in the orthogonal model. And we can see that our MSCA, I think it's also worse. But we can interpret the rest of the model the same way, looking at the factor loadings here, the correlations here, which is set to zero, which doesn't is not very informative, and the variances here. Okay, but we only dealt with a continuous variable. How do we have a model with ordered variables? So usually for ordinal variables, we use the estimator WLSMV, and we put the argument order to be true. So we'll use an example from the Big Five, which is the 5 factors of personality traits. And this data set is from the Psych package. So we have 5 items for each factor. So we set up this factor here. So agreeableness factor is composed of items A1, A2, A3, and A4, A5. And the same logic follows for the other factors. So conscientiousness, extroversion, neuroticism, and openness. So you can see that we only will change 2 arguments here. So first we have the model that we set up this beforehand, the data from the psych package, and the estimator, which we change from maximum likelihood to WLSMP. The thing from WLSMP is that this estimator controls for type 1 errors, and it's better to estimate the factor loadings. And we also put the order argument to be true, okay? So you can see that we have some differences in the output. The first difference is that we now have 2 columns of results. We have the standard column and the scale column. The standard column is just the WLSMV results, and the scaled column is the WLSMV results. So this is the WLS, and this from the WLSMV. Okay, so this is what we will consider when we have the ordered argument equal true. So we'll just look at the model test user model from the last column, and the same for CFI and RMSEA. Okay. And we also have a difference here because we have a latent variable and all that, the covariance, but we also have some intercepts, which is set to 0. And we have the thresholds. So this is a Likert scale. I think it's from 1 to 6. So we have 5 thresholds. And I think that is interesting to see is if the threshold is ordered. So the first threshold should be below the second, that should be below the third, that should be below the fourth, and so on. And we also have the variances again of the items and the scales, but we usually just interpret the thresholds, the fit index, and the factor loadings and covariances. So this is the summary of everything from CFA. I know it was really fast than usual, but you can see more about this in my book. So I'd like to have this uh, open for more questions if you have any. Let me see the chat here.
I think we have one question in chat.
About the factor loading, right?
Yeah, yeah.
Yeah, so the question is, in factor loading results, why p-value is not there for the first item? Because when we are estimating the CFA, we have to have we need to have kind of a parameter to estimate the other factor loading. So we set the factor loading of the first item to 1, and therefore we cannot calculate the p-value since we are not estimating it. We're just fixing it to 1 and using this as a parameter to estimate the other items factor loadings. Okay. But we can also interpret the factor loading of the first item by the standardized solution, which is easier than just assume that it's 1. So do you have any other questions? So I can share the
Yeah,
slide,
this
yeah.
slide. Yeah, this slide. Yeah, it will be shared. Don't worry.
And I think the R code was also shared as well, right?
Yeah, the R markdown has already been sent.
So we have some differences between exploratory and confirmatory factor analysis. Usually the exploratory factor analysis is more atheoretical, which, well, because we are testing if the number of factors are happening the way we want to, using parallel analysis or eigenvalue greater than 1. So it's it's not a theoretical, but it's usually tested as it was, thinking as it is a theoretical. And also in exploratory factor analysis, we can estimate the fit indices. However, uh, there are a lot of simulation studies showing that those fit indices usually will yield good fit even if the model is not the correct model. So in confirmatory factor analysis, this does not happen in these types of model that I presented here. It only happens in bifactor models and exploratory factor models. So I think those are the main differences uh, about the fit indices and how to estimate the number of factors.
If anyone wants to unmute and say something or ask something, just raise your hand. We will allow you the option to unmute. We have one question in chat. How do you decide on the number of factor loadings of a latent variable?
So the factor loadings is actually what we estimate to see the relationship between the the latent variable and the items. So the factor loading, we want to see if we have a magnitude to explain the latent variable, okay? So how do you decide the number of factors, the number of factors on a latent variable? We have to, we can test this with exploratory factor analysis beforehand to see which items load to each factors, but we can also have a theory uh, to to use this to test this model. So when we are building an instrument, we are not building an instrument without theory. We usually write in items to say, okay, these items belongs to the depression factor. So in the theory that I'm building, the depression factor is only one factor to explain all the items. So basically, I would say that in CFA, we use theory and other studies as well that uses exploratory factor analysis or confirmatory factor analysis to set the number of factor loadings that we have. Okay.
We have another one. While
While
defining the
defining
model,
the
we
while defining the model, we have defining an additive model. We can have a multiplicative model. Well, I don't think that in Lavan we can have a multiplicative model. I think this might be the case of using other packages. But yeah, so there is the difference between the ML and WLSMV. So the difference is that maximum likelihood uh, does not deal with ordered variables in a good manner. So when we have items that are responded in a Likert scale, we are assuming in the maximum likelihood that this Likert scale follows a normal distribution, which does not hold when we have ordered variables. So that's why we have some bias in the estimates of maximum likelihood when we are dealing with ordered variables. And the WLSMP deals better with disordered variables and it controls for the type 1 error. So WLSMV should be used when the response scale is less than 5 points, but also less than, I think, 10, I think is the maximum number of categories for WLSMV. It's just because they are ordered variables. So that's why we need to use another estimator to deal with ordered variables. Yeah.
okay. I don't see any more questions in chat. Um,
Mhm.
in in case anyone wants to speak or anything, just raise your hand. Rafael, would you also like to share about the book you just launched? I think many people would like to know more about it.
Yeah, I can put the link here in the chat and also talk about it. Let me just
Yeah,
have the link
yeah, that
here.
will be great.
So this is the link of the book, and we have a lot of. I wrote a lot of chapters for this book. So I wrote about the validity concept of psychological tests and talk about classical test theories and what is the theory of latent variables in psychometrics. I also wrote about what is it possible to measure psychological variables using measurement theory. And for the ones that asked about exploratory factor analysis, there is a chapter on exploratory factor analysis, a chapter on confirmatory factor analysis, and exploratory graph analysis. And also we have chapters on social desirability bias that affects the estimates of the validity and accuracy bias that also affects the evidence of validity. Also have chapters on measurement invariance to see if to test if there is differences in the model between groups and non-parametric item response theory. And I also share a step-by-step on how to validate uh, an instrument. So yeah, it's all free, so you can read it for free. And there is a lot of examples using our software. So you can replicate this in your computer just by following what the book is stating there.
Okay, that's great. Thank you so much for sharing, Rafael. Um, and I don't see any more questions in chat. And I think we still have like some 15 minutes more. Is there anything else we can cover?
I can make myself available as well. I know that the flyer for this event, this workshop, it states my Twitter, so you can contact me on Twitter so I can answer your questions. So there's no problem in that.
Yeah, that's great. And also, we will be sending all the resources later on. So we will also be adding all the links. Okay, so uh, thank you so much, everyone. And thank you, Rafael, for this wonderful workshop. And thank you for sharing all the resources. Um, yeah, thank you so much. We really appreciate everyone who joined, especially from different time zones. So thank you so much for joining. And we will be sending these resources. Uh, Rafael, is there anything else you want to share before we end?
I'd just like to thank everyone as well. So thank you for being here on a Sunday, and thank you for asking very insightful questions. Hope you liked the book. Hope you liked the workshop. And I'm available if anyone wants to collaborate, if anyone wants to ask questions. So yeah, thank you so much.
Okay, great. Thank you so much, Rafael. This was amazing. And thank you, everyone, for joining. We have recorded this session and we will be sending this and uploading it on YouTube as well. And we will be sending the resources soon. So, yeah, with that, I think we are ready to end. So, thank you so much.
Thank you all. Bye bye.